we will discuss velocities and acceleration. I'll start with something simple. I have a motion of an object along a straight line. We call that one-dimensional motion. And I'll tell you that the object is here at time t1. At time t2 it's here, at time t3 it's there. Time t4 it's here, and at time t5 it's back where it was at t1. And here you see the positions in x where it is located at that moment in time. I will define this to be the increasing value of x. It's my free choice, but I've chosen this now. Now we will introduce what we call the average velocity. I put a bar over it, that stands for average.
Thank you, Walter. Just another quick one on SUVAT. This one is going to be S equals ut plus half at squared, where S is displacement or distance. Don't forget there is a slight difference between displacement and distance. Initial velocity is u meters per second, and time is time in seconds, and acceleration is acceleration in meters per second So in these ones we're just going to use S equals ut plus half at squared. You could, if you wanted to, put a bracket round there and a bracket round there like that, and a bracket round there and a bracket round there like that. And it is t squared. It's not a t squared or half a t squared, it's just a t squared. Just in case. So the first question, we've got a bike accelerates from rest at 0.1 meters per second. We need to calculate the distance, s, travelled after 15 seconds. So there's no tricks here, we're just using that formula. Write down what you know. U equals 0 because it's from rest. Acceleration is 0.1 meters per second, and the time is 15 seconds. Correct units, so everyone's a winner. We've got to find the distance, we'll use that formula there. S equals ut plus a half at squared. Put it in, obviously u is 0, t is 15, a is 0.1, and t is 15. 0 times 15 in my book is 0. So we can get rid of that. So we're just looking for this, half times 0.1 times 15 squared. So 0.5 or half times by 0.1 times by, it's the 15 squared. That'll give us how far it's gone in that time. 11.25 meters. Nice and easy. Scroll down. Another one. This one's a jet. Starting velocity of 3 meters per second. Accelerates for 2 meters per second. 20 seconds is the time we need to gain to work out the distance travelled by the jet. So we need to work out distance. U is 3. A is minus, no it's not, it's 2. Be careful, there's 2, it's meant to be equals. T is 20 seconds, and S, distance, we don't know. So there's the formula again, which is what you'll be using for these questions. S equals ut plus a half at squared. Don't forget the squared. So we know u is 3, we know t is 20. A is 2 and time is 20. So in your calculator you can either do all in one go like that or break it down like I've done. So 3 times 20 close brackets plus 0.5 times 2 times 20 squared close the bracket equals 460 meters. Thank you very much. So that jumbo jet has gone 460 meters in that time with that starting velocity and that acceleration. So nice and easy, nothing really to stop you from doing stuff there. This one, same formula, but I've got kilometers per hour in this one, and we don't want to be in kilometers per hour because we want to be in meters per second. So a car with starting velocity of 2 kilometers per hour, accelerate at 0.25 meters per second. That's in the right unit, so that's all right. It goes for 0.5 minutes. Don't forget we need to be in seconds. We have to convert that into seconds, and we need to know how far distance, displacement s. So if I was you, first thing we need to do is convert that 2 into meters per second. Easy way of doing it. 1 kilometer is 1,000 meters, and 1 hour has 60 times by 60 seconds, because there's 60 seconds in a minute and 60 minutes in an hour on Earth anyway. So the first thing I'm going to do is convert that 2 into meters. So 2 kilometers is 2,000 meters. So it's 2,000 meters per hour. We want to be in seconds, so you need to divide the meters by how many seconds in an hour, which is 60 by 60, which gives you this. So on your calculator you can do it like that if you want to. 2 times 1,000. I'll put some brackets around it for a laugh. Thank you very much. Brackets round it there, look. Come down here. Come down here. 60 times 60 is 3,600, but we'll do it anyway. Close that. Equals 5/9, that's too bad. 0.55555555. 0.56 meters per second. So that is our starting velocity. While you're there, 0.56 is the starting velocity, meters per second. Acceleration is 0.25, and 30 seconds because it's 0.5 of a minute. So 60 times by 0.5 will give you 30 seconds. Don't use 0.5, use 30 seconds. Then it's just a case of using that formula there, S equals ut plus half at squared. We know u, we know t, we know a, and we know t. Make sure you use the meters per second and the seconds. So in your calculator, 0.56 times by 30, close the bracket, plus 0.5 times by 0.25 times by 30 squared, close bracket, equals 129.3 meters. Thank you very much. So the car's gone 130 meters in that time. So 1, 2, 3 questions, nothing too hard. The only thing you need to keep an eye out on is make sure everything's in meters per second and everything's in seconds. And you should be alright. Write down what you know and go from there. Obviously, if it's from rest, you know u is naught. So, yes, over and out. Thank you very much. North Star.